This is SARS-CoV-2. It belongs to the family of coronaviruses named for the crown-like spikes on their surfaces. SARS-CoV-2 can cause Covid19, a contagious viral infection that attacks primarily your throat and lungs. What actually happens in your body when you contract the coronavirus? What exactly causes your body to develop pneumonia? And how would a vaccine work? The coronavirus must infect living cells in order to reproduce. Let's have a closer look. Inside the virus, genetic material contains the information to make more copies of itself. A protein shell provides a hard protective enclosure for the genetic material as the virus travels between the people it infects. An outer envelope allows the virus to infect cells by merging with the cell's outer membrane. Projecting from the envelope are spikes of protein molecules. Both a typical influenza virus and the new coronavirus use their spikes like a key to get inside a cell in your body, where it takes over the cell's internal machinery, repurposing it to build the components of new viruses. When an infected person talks, coughs, or sneezes, droplets carrying the virus may land in your mouth or nose and then move into your lungs. Once inside your body, the virus comes in contact with cells in your throat, nose, or lungs. One spike on the virus inserts into a receptor molecule on your healthy cell membrane like a key in a lock. This action allows the virus to get inside your cell. A typical flu virus would travel inside a sac made from your cell membrane to your cell's nucleus that houses all its genetic material. The coronavirus, on the other hand, doesn't need to enter the host cell nucleus. It can directly access parts of the host cell called ribosomes. Ribosomes use genetic information from the virus to make viral proteins, such as the spikes on the virus's surface. A packaging structure in your cell then carries the spikes in vesicles which merge with your cell's outer layer, the cell membrane. All the parts needed to create a new virus gather just beneath your cell's membrane. Then, a new virus begins to bud off from the cell's membrane. Now, with the virus spreading in your body, how can you develop pneumonia symptoms? For this, we'll have to look into your lungs. Each lung has separate sections called lobes. Normally, as you breathe, air moves freely through your trachea or windpipe, then through large tubes called bronchi, through smaller tubes called bronchioles, and finally into tiny sacs called alveoli. Your airways and alveoli are flexible and springy. When you breathe in, each air sac inflates like a small balloon. And when you exhale, the sacs deflate. Small blood vessels called capillaries surround your alveoli. Oxygen from the air you breathe passes into your capillaries, and then carbon dioxide from your body passes out of your capillaries into your alveoli so that your lungs can get rid of it when you exhale. Your airways catch most germs in the mucus that lines your trachea, bronchi, and bronchioles. In a healthy body, hair-like cilia lining the tubes constantly push the mucus and germs out of your airways, where you might expel them by coughing. Normally, cells of your immune system attack viruses and germs that make it past your mucus and cilia and enter your alveoli. However, if your immune system is weakened, like in the case of a coronavirus infection, the virus can overwhelm your immune cells, and your bronchioles and alveoli become inflamed as your immune system attacks the multiplying viruses. The inflammation can cause your alveoli to fill with fluid, making it difficult for your body to get the oxygen it needs. You could develop lobar pneumonia, where one lobe of your lungs is affected, or you could have bronchopneumonia that affects many areas of both lungs. Pneumonia may cause difficulty breathing, chest pain, coughing, fever and chills, confusion, headache, muscle pain, and fatigue. It can also lead to more serious complications. Respiratory failure occurs when your breathing becomes so difficult that you need a machine called a ventilator to help you breathe. These are the machines that save lives and that medical device companies currently ramp up production for. Whether you would develop these symptoms depends on a lot of factors, such as your age and whether you already have an existing condition. While this all sounds scary, the push to develop a coronavirus vaccine is moving at high speed. Studies of other coronaviruses led most researchers to assume that people who have recovered from a SARS-CoV-2 infection could be protected from reinfection for a period of time. But that assumption needs to be backed by empirical evidence, and some studies suggest otherwise. There are several different approaches for a potential vaccine against the coronavirus. The basic idea is that you would get a shot that contains faint versions of the virus. The vaccine would expose your body to a version of the virus that is too weak to cause infection, but just strong enough to stimulate an immune response. Within a few weeks, cells in your immune system would make markers called antibodies, which would be specific for only the coronavirus, or specifically its spike protein. Antibodies then attach to the virus and prevent it from attaching to your cells. Your immune system then responds to signals from the antibodies by consuming and destroying the clumps of viruses. If you then catch the real virus at a later stage, your body would recognize it and destroy it. In other words, your immune system is now primed. Collecting evidence on whether this will be possible, safe, and effective is part of what's taking researchers so long to develop a vaccine. It's a race against time to develop a vaccine amid a pandemic. Each step in vaccine development usually takes months, if not years. An Ebola vaccine broke records by being ready in 5 years. The hope here is to develop one for the new coronavirus in a record-breaking 12 to 18 months. While all this will take time, stay home if you can, to protect the most vulnerable. And don't forget to wash your hands for at least 20 seconds and as often as possible. This video was a collaboration between Nucleus Medical Media and the What If channel, where we usually dive into hypothetical scenarios about the human body, humanity, our planet, and the cosmos. Check out our channel by visiting the link in the description below.